All right, so what we're doing now is we're applying using the definition of a derivative. It doesn't really matter which version of it we use. I typically like to use this one as x approaches a if I'm gonna do it, just because it makes things a little easier than having to deal with h's and all of that excess stuff. So these ones say to find the derivative of the function and use it to find the equation of the tangent line to the curve at x equals 3. So we've got y equals 2x squared minus 13x plus 5, and we're doing it at x equals 3. So a lot of times when I'm using the f of x minus f of a over x minus a, what I'll go ahead and do is like actually find f of a. So like in this case, f of 3, just so that when I go to plug it in, like I'm just plugging in a number and not like having to write all that extra stuff. So f of 3 is 2 times 3 squared minus 13 times 3 plus 5. So what is that? 9, 18 minus 39 plus 5, negative 16. Does that sound right?
Well, I need to think about it.
You want to confirm?
Oh, yeah, that does sound right. Okay. Yeah, I concur.
Okay.
I just needed to look at it a little bit, you know.
All right, so now the limit as x approaches a, so x approaches 3, of f of x, so we just copy this down exactly as it is, so 2x squared minus 13x plus 5 minus f of a. Well, f of a is negative 16, so that's going to be plus 16 all over x minus 3.
Forgot that we had something on the bottom.
So as
Right.
top simplified would be 2x squared minus 13x plus 21 over x minus 3. Now, I would personally see if you can factor, because obviously that makes life way easier to do things if I can. So, limit as x approaches 3. What you may do, what I like to do a lot of times, is to factor off to the side so that I'm not writing steps over and over again where I'm like factor by grouping inside of a limit. I'll just like find it and then I'll just throw it over here. So factors of, what is that, 42 that add up to negative 13.
You got this, Virginia, already.
-7 and -6.
Yep.
Okay.
2x squared minus 6x minus 7x plus 21. So
It's
then,
always good to order them in a certain way.
yeah, I was trying to explain to a class the other day about why I order things the way that I do, and they kind of just looked at me like I was crazy. I was like, okay, well, okay.
No, they're the crazies.
I was like, I mean, some of them it really doesn't make a difference. Like, it's not going to change anything. I mean, and it doesn't matter ultimately which way you do it, but I try to, like, look at which numbers match up. Like, I wouldn't have put 6 and 21 together, even though I definitely could have.
You could put 6 and 21 together, but 2 and 7.
Yeah. Well, yes, like, that's just annoying. So I'm like, okay, well, 7 and 21 make the most sense, and then even numbers, you know, whatever. So 2x times x minus 3 minus 7 times x minus 3. So then now in my limit, I can put 2x minus 7 times x minus 3 over x minus 3. Cancel the x minus 3's. If I plug in 3, then what do I get?
-1.
-1. So this is the slope of the tangent.
We're still doing that.
Yeah, it says to write the equation of the tangent line.
Yeah. I'm here, I promise.
So then our x coordinate is 3, our y coordinate is negative 16. Right? Okay. Making sure everybody's following. So y plus 16 equals -1 times x minus 3. Or I can say y equals negative x plus 3 minus 16. So y equals negative x minus 13. Now that one just wanted the tangent. The next one wants the tangent and the normal. Um, 20. Y equals the square root of x. X equals 4.
So I think my slowness is about to show just a tad, but I guess like we now have a new thing to find the slope of the tangent.
Yes. We're just using the definition of a derivative.
I love that I just picked up on that.
Essentially, we take the derivative, evaluate it at a point, and that's our slope. But we're using the definition of a derivative to do it right now.
So we're deriving the slope of the definition.
Yes. All right, f of 4, square root of 4 is 2.
Are we only taking the positive?
We're just saying that's equal to that. We didn't take the square root of both sides. Like this was already shown to be positive. Josh is struggling today. He's like lagging.
That happens. That happens. When the code starts going.
The computer program is not functioning today.
It's a glitch in the matrix.
Oh, we were talking about that in Algebra 2 earlier.
Oops.
An error in the code.
Well, no, just about the movie The Matrix. And I said, wait a minute, I just want to clarify, I'm not suggesting you go home and watch that movie.
Just put that out
All right.
Zeros in there.
F of x, so square root of x, minus f of a, so that's 2, all over x minus 4. Now I'm going to show you a really, really crazy trick right here that you've probably not seen before. The limit as x approaches 4
I'm not gonna write. I'm just gonna watch.
of square root of x minus 2. This right here is a difference of squares.
Makes sense.
Square root of x plus 2 times the square root of x minus 2.
It's like magic.
I know, right? Isn't it awesome? It's like we're in the chocolate factory.
Makes sense.
I'm so like wonked out at this
Why?
point.
I know. It's taking me like
I mean, it really does make sense that it would be like that. It's like crazy, but like it makes sense.
I know, right? Like you wouldn't have known that was a difference of squares if I hadn't told you, would you?
I mean, once you said it, it's like, oh well, yeah, I guess it could be.
It's wild.
very crazy.
That's insane.
I feel like I just blew Josh's mind.
You flipped the switch.
He was like lagging, and then he's like,
The light got turned on.
so that stuff
Love
cancels. So now I have the limit as x approaches 4 of 1 over the square root of x plus 2.
Okay, I don't like it anymore. Why did it just have to be 1?
Because everything canceled.
But I don't like it when there are square roots on the bottom.
Plug in 4.
Oh, well,
Oh.
It's a limit.
well, limits are limiting my brain capacity.
I can tell.
I feel like we switched for a day or something.
Virginia's like on it, and Josh is like, I don't know what's
I
happening.
feel like I'm like looking
Virginia,
in the
what's
mirror
it?
right now.
What's it like being smart?
Feels pretty nice.
All right, when I plug in 4, what do I get?
Virginia.
I mean, I would pull Josh. I'll let you take this one.
Yes. Yes, ma'am. It's 1/4, I think.
1/4, he
I
thinks.
think.
I think. Therefore, I am.
Rene Descartes.
Oh, by the way, the other day I was playing a game on my phone. I got to this like cut scene. Then there was this little robot that said, "I think, therefore I am."
Did I send y'all the clip from Fuller House the other night when I was watching it?
Yes.
Okay, I couldn't remember if I did or not.
Yes.
Because it was kind of late. So I was like, I don't remember if I actually sent it or not.
I did. I love that. And also, I was
Took a
doing
screenshot of
SAT
it.
practice the other day, and there was the quote.
Keep forgetting about that.
I have a calculator like picture on my phone that's a calculator talking, and he says, I think, therefore you don't.
I think there's
All right, so the point is 4/2 for the tangent. Y minus 2 equals 1/4 times x minus 4. So y equals 1/4 x minus 1 plus 2. So y equals 1/4 x plus 1.
The other day,
What's
when we had that calculus test, when I was doing the tangent line, I had the wrong like y-intercept thing, because I think I put a number in wrong. I put it in the graph and I was like,
He was
why isn't
lagging.
it lining up? And then I fixed it,
I
and
think
then
I
it was
messed
good.
up some stuff on that test. Oh well. I tried my
And yes,
It probably will get graded tomorrow because I have a lot of quizzes and tests being given tomorrow.
I definitely am lagging. My apologies.
You
What's
have a
the
lot of free time now.
what's the slope of the normal line?
-4.
So y minus 2 equals -4 times x minus 4. Y equals -4x plus 16 plus 2. Y equals -4x plus 18. And there's my normal. Boom. Done. You now know how to do derivatives. For now.
That's not ominous at all.
For now. 3, 5, 7, 11, 17, and 19.
Should I be scared?
Perhaps.